introduce, the data recording system we use, what data we make available, and alongside all of that, the hierarchy and the decision-making process inside the research team and the specializations of the people in it. None of these are neutral. Each one is a lever that bends the eventual published interpretation. And in archaeology, unlike in much of the so-called hard sciences, very few of these levers are governed by internationally accepted minimal standards. We have excellent guides, but as I argue in the paper, guides are not the same as universally accepted minimal standards, and the absence quietly shapes how comfortable and how comparable, how reproducible our results actually are. This slide is dense, so let me hit the highlights rather than read every line. The variables and biases that shape how we explain archaeological evidence are the cumulative character of archaeological knowledge. What we believe today rests on top of what someone else believed yesterday, and that earlier belief was produced inside its own socio-cultural and historical context. Second, the role of first researchers in any region, in any field. The scholars who establish what I call the orthodox narrative, their expertise, their education, their ethics, their political engagement, and yes, their biases. Third, the overreach of the alpha researchers, whose interpretations becomes canonical when it's not subject to critical scrutiny by the junior scholars who succeeded them. Fourth, the absence of critical mass of researchers working on similar problems, and the absence of a proper critical apparatus inside the academic environments. Fifth, the systemic neglect of data that does not corroborate with established narrative. Sixth, the over-reliance on analogy, borrowing explanations from elsewhere instead of patient considering of the on-site evidence. And finally, the perennial problem of region, whether a pattern observed in one geography can legitimately be transferred to another. The second list extends the first. Without going through in line by line, the additional issues are failing to account for the wider macro regions and macro sociocultural context, the absence of problem-solving approach to research design. We excavate, then ask what we found, instead of asking what we want to know first. Engaged research, where the goal is to prove a particular truth rather than to test it. Over-interpretation of ethnicity in demographically fluid past environments, a real hazard in the Roman provincial context where most of us work. And imbalances between the quantity and the quality of data drawn from different sources, especially the written sources. Add to that the distorting effects of sensationalism, elitism, academic and cultural imperialism, the embedded conservatism on our narrative, isolation from current developments in theory, methods, and technology, a real problem for researchers in developing countries with limited access to bibliography, technology, and funding. And finally, recognizing and admitting that there are limits to what archaeological data can and should answer, relying solely on material evidence. The takeaway for this whole sequence is short, and it's on this slide. So much information is missing from the archaeological record, and we have so many cognitive biases about the bits of information that we do recover. That is why any honest interpretation must make those gaps and those biases visible. The naked archaeologist concept is, at its core, a proposal for how to make them visible. Archaeological research, framed in the way I am proposing, is a cluster of knowledge, a network of nodes, with evidence circulating between them, and the structure of that network is itself part of the explanation. Two references are important here. The first is the volume Communities and Knowledge Production in Archaeology, published in 2020. The second is Monica Milosavljević's paper, How Archaeological Communities Think, Rethinking the Concept of Thought Collective, presented at the 21st annual meeting of the European Association of Archaeologists in Glasgow, held back in 2015. What both make clear is that the archaeological knowledge is not produced by individuals. It is produced by communities, by clusters, by what Ludwig Fleck called thought collectives. Empirically, we can see that nodes of these networks the nodes of these networks in citations, in collaborations, in who trained whom. Informations and ideas circulate inside those networks, but they also stop at their boundaries, which means the landscape of reasoning is, at least in part, the landscape of these communities. Let me now ground the argument in a concrete site, the archaeological site of Kukul near Prilep in Macedonia, also known by the local name Baba, which on Slavic means grandmother. What you see here is an on-site grid spatially consistent with the grid in official topographic maps. It was first, the grid was embedded in GIS environment and later on the site itself. The spatial layout is 4 quadrants, kilometer on kilometer, with 1,600 sectors, 50 on 50 meters, and 160,000 squares, 5 on 5 meters. The grid is not just a convenience recording. It is the primary spatial referencing system for which every observation, every find, every photograph, and every drawing inherits its spatial exactness. Whoever comes to the research on the site, maybe 500 years from now, can easily reconstruct the whole grid system and relate it to the existing documentation based on the information of one existing trench in the field and the coordinate system. Different archaeological situations on the site were documented with 7 textured models produced through image-based modeling. Spatial exactness here is non-negotiable. This image shows in blue the proposed perimeter of the Hellenistic period settlement at Kukul Baba and marked excavation trenches. I want to stress the word proposed. This is a hypothesis, a competitive account whose probability we evaluate against the available evidence. It is not a fact. Beyond the textured models, we record immovable architectural features, walls, floors, thresholds, drains, as discrete spatial objects in the GIS, each with its own attributes. This is the layer at which the extended matrix logic, which I will introduce in a moment, can begin to bind material evidence to interpretation. Everything we have just looked at, the grid, the textured models, the proposed perimeter, the immovable finds, belongs to the data mining and data recording stage. The point I want to carry forward is this. Data quality at this stage determines the ceiling of everything that follows. The initial finds from the excavations were presented at the conference of the Macedonian Archaeological Society back in 2021, just a month after the excavations ended. The following images are a very naive way of finds presentation and interpretation. Each of these finds has a unique spatially exact identifier that traces back to the grid I showed you 2 slides ago. Still, beside the effort, establishing the spatial connection, horizontal and vertical, to stratigraphic units, to rooms, to buildings, while assessing other relevant plausible explanations just on a photographic record was with limited success. Just a situation, these finds were recorded before a walking level in a soil layer deposited as part of an adaptation carried out as early as the time of Tiberius, between 578 and 558, to the north of a room. I draw your attention to this slide because it is exactly the kind of context in which multiple reasonable interpretations compete. Was this material deposited during the adaptation, or was it sealed by it? The data we record and the way we structure it must be capable of supporting that conversation, not closing it down. This is the context I was talking about. And there must be a better way to present the results. The next slide states the problem properly. This brings us to the problem statement of this entire talk. There are 4 problems and 1 meta problem. The first 3 are representational. How do we explicitly represent and interpret the complex 3-dimensional geometry of a stratigraphic unit? How do we explicitly represent and interpret the movable finds and the surrounding context, the artifacts, the ecofacts, and biofacts? And how do we interpret transparently, taking into account all the data available, weighted for relevance and reliability? The 4th problem is epistemic. What about the uncertainties, the openings that should exist for alternative interpretations? And the meta problem, where in our publication is the reasoning behind all of this? The toolkit I propose has 4 components: the extended matrix tool logic, the ATON framework for interaction with data in 3-dimensional environment, explanation before inference, and inference before explanation as reasoning strategies. Let me take each in turn. The extended matrix is a tool for virtual reconstruction in archaeology, developed primarily at the Institute for Heritage Sciences in Rome. The key publication is Emanuel Demetrescu's 2015 paper in the Journal of Archaeological Science, Archaeological Stratigraphy as a Formal Language for Virtual Reconstruction, complemented by the 2021 5-step method paper by Demetrescu and Ferdani in Applied Sciences, which consolidates the workflow we are proposing today. The pipeline has 4 steps. Image-based modeling, structure from motion, data acquired by aerial and terrestrial survey. Then Blender software is used with the extended matrix Blender tools add-on. 3rd step is yet graph ML editor with the extended matrix template. And 4th, development of the stratigraphic unit matrix visualized in yet. The development of the matrix combines on-site stratigraphy with data drawn from publications and archival documentation. The image-based models are the spatial backbone. The matrix is the logical backbone. Visualization in yet can be done manually or assisted with the PRHinit plugin for QGIS. Step 1 is the image-based modeling, by structure from motion acquired by field or terrestrial survey. The product of this step is the spatial record to which everything else is related to. Step 3 uses the YetGraph ML editor with the extended matrix template, visualizing the matrix either manually or via the PRHinit plugin for QGIS. The graph is the place where reasoning becomes inspectable. Inside Blender, with EM tools, extended matrix tools, we built proxies, volumetric representations for every single identified stratigraphic unit. The proxy is not the reconstruction, it is the placeholder onto which evidence and reasoning attach. At Demetrescu and Ferdani state, the extended matrix is fundamentally a visual, node-based formal language grounded on a stratigraphic approach, designed for virtual archaeology and built on the theory of knowledge graphs. One phrase is of critical importance. Knowledge graphs are the data structure on which modern reasoning systems are increasingly built, and the extended matrix puts archaeological stratigraphy on exactly on that foundation. I want to acknowledge that the other approaches exist. Nobles and Roosevelt's 2021 paper in Open Archaeology on filling the void with 2D points clouds to 3D volumes, and the 2021 paper on scan to building information model in 3D GIS environments are two examples. The choice of extended matrix here is not exclusive. It is simply the one that fits best with the formal language requirement that explanation before inference and inference before explanation place on us. The logic of the extended matrix is built around a set of node types in the reference sheet. Without going through every node, of critical importance for our purposes today are the stratigraphic unit and collective or special find node, the source document node, the extractor node, and the combiner node. The extractor node captures the simple information from a source or document without interpretation, while the combiner node provides the interpretation, explanation, our understanding that draws on at least one extractor. This is the formal hinge of our reasoning system. It separates what was observed from what is being claimed, and it does so at the level of a single graph edge. The full taxonomy of extended matrix nodes lets us attach properties to the material evidence, link them to specific stratigraphic units, and tag everything with unique identifiers. Each extractor and each combiner has its own ID. The result is a graph in which we can ask of any stated conclusion, which observation supported, and through which chain of explanations. What this look like is practice on Kukul excavation. Every stratigraphic unit recorded becomes a node, and every find record inherits a unique ID while linking it to the stratigraphic unit and to the spatial grid. The data recording system should facilitate the creation of a specific inventory that includes unique IDs automatically generated by combining alphanumeric values for specific spatially exact quadrants, sectors, squares, locuses or lots, and baskets or a specific find number. Under locus, we consider a specific stratigraphic unit identified by a unique number, which corresponds to a precisely defined excavation unit or square. This practice enhances the data resolution and improves the quality of the data recording system, particularly when dealing with larger stratigraphic units that spread over extensive areas. To eliminate the problems emerging because of the added complexity, every locus should be related to a particular stratigraphic unit. The unique identifier will show the exact geographical and stratigraphic location of the find. For example, unique ID 288G22503 means that this was the third recorded find in the 25th stratigraphic unit documented in square G2, part of sector 88 inside the second quadrant. Every interpretative claim that this is an adaptation layer, that this wall belongs to horizon 2, appears as a combiner node tied to the specific extractors. If one extractor later turns out to be misidentified, the chains of reasoning that dependent on it can be revised rather than silently invalidated. Every level of that hierarchy has exact spatial parameters. Voxel for volumetric representation like the stratigraphic units, or vector layer like points, lines, and polygons. D&DCure, or Digital Environments for Digital Cultural Realities, is the GIS-oriented data recording system we have been developing. It is published online as a web GIS app. The system is built around a relational database that stores information about locuses, stratigraphic units, and archaeological features. The data entry forms for the full range of movable finds: pottery, glass, bones, lamps, coins, terracotta figurines, sculpture, epigraphy, botanical faunal materials are yet to be developed. A short reference here to the work of Marcos Katsianis and colleagues at Palimbela Kolindros in Greece. Their 2008 paper in the Journal of Archaeological Science on a 3D digital workflow for archaeological intrasite research using GIS is a foundational reference for what we are doing. And the workshop video at the link on the slide from the Aegis Athena Mapping the Past, Plotting the Future workshop is well worth watching. The ATON framework developed by the Institute of Heritage Sciences in Rome is an open source Web3D and WebXR framework for cultural heritage. The link on the slide takes you to the Seripola site example. It's located near Orte, Italy. ATON framework is what allows the data and reasoning recorded inside the extended matrix to be experienced by a colleague, by a student, a member of the public throughout a browser in virtual environment, and to be queried interactively. For example, if you now in the moment scan this QR code, we will go directly to Seripola site. Imagine this is like an excavation of one trench on some site. Considering the previous slide, the system should allow for stratigraphic units, for finds to be turned on, turned off, and we can discuss everything in a virtual environment. We can present these finds, and we can we can bring it to the public, or to the colleagues, closer to the public or to the colleagues. Now let me turn to the reasoning structure. EMVIC, Extended Matrix Visual Inspector and Querier, closes the loop. It is the virtual publication endpoint, a tool that lets a reader navigate the reconstructed scene. By reconstructed, I mean from the site that was excavated. Click on a stratigraphic unit and trace the reasoning back through extractors and combiners to the underlying records. This is what open access to reasoning looks like in practice, not just open access to PDF documents. Now let me turn on to the reasoning strategy itself, beginning with the explanation before inference as a prior step. The point of EBI is this: before you can compare hypotheses, you need a clean, formal account of what you are explaining and based on what evidence. EBI sets up the formal foundation. In our system, EBI is what the extractor and combiner nodes implement at the graph level. We do not infer first and explain afterwards. We make the explanation explicit, and then we infer over the explanations. The order matters. If you skip EBI, IB collapses into intuition. Inference to best explanation is, as Danilo Campanaro put it in his 2021 paper in the European Journal of Archaeology, an old tool, new model. The basic move is familiar to anyone who has tried to analyze competing hypotheses. Given a set of hypotheses, you ask which explanation among the candidate explanations best accounts for them based on the available record. Best in terms of scope, simplicity, coherence with background knowledge, and so on. Here we must note that Lars Vogel in 2007 paper in American Antiquity argued that processual and post-processual archaeologists, despite their rhetoric, in fact share the same underlying epistemology, and that reasoning strategy is exactly inference to best explanation. What eBay does for us in the context of the naked archaeologist concept is provide a transparent way to compare interpretations. Once the data and the simple observations are recorded as extractor and combiner nodes, competing explanations can be evaluated against the same evidence. The reader does not have to take our word for which interpretation is best. They can inspect why we think so. There are few pieces of context for where this work sits in current practice. The naked archaeologist concept assumes a reproducible research stance. When considering the methodology I have just described, it is essential to account for the use of R programming language for the existing tools that support reproducible research and for the potential development of new tools in this space. If our reasoning is to be auditable, the code that produces our figures, our statistics, and our spatial analysis must travel with the publication, not as a footnote, but as a first-class object of the publication itself. The Digital Archaeology Bern workshop held in February 2023 focused exactly on writing reproducible research with R and the RR Tools package. Ben Marwick's 2017 publication in the Open Science in Archaeology is the natural companion text. Regarding the artificial intelligence, we live in an era shaped by the extensive use of AI. As these technologies grow more sophisticated, the provenance of data, the traceability of sources, of reasoning, and of interpretation has become the key safeguard distinguishing reality from the generated context. Provenance is the technical bridge that makes the cognitive transparency I have been advocating possible. Establishing provenance preserves the authority of information nodes that provide verified data in a landscape of unverified AI generations. The verifiable record of an item's origin, its custody, and its transformations is a critical defense mechanism in an era of generative AI. Without clear provenance, the information ecosystems becomes vulnerable to mass disinformation, and particularly to deepfakes. The example of this slide, the tripjive.com page that fabricates a Prilep's historical landmarks narrative, is exactly the kind of generated context that erodes public trust in genuine heritage research. Two references underpin this argument. Jampolsky and Spellchecker's 2016 paper reminds us how routinely AI systems fail in ways their builders did not anticipate. And other paper from 2022 establishing data provenance from responsible artificial intelligence systems give us the responsible AI framework: fairness, accountability, transparency, and explainability, built on top of a clean data provenance. The C2PA standard for content credentials is the baseline for this. It is the same problems we face in archaeology, thus just at a different scale. How do we let a reader to audit where a piece of information came from? The argument is symmetrical. What the naked archaeologist concept asks for inside our discipline, extractors, combiners, unique identifiers, open access to the chain, is the same thing the broader information environment is now asking for under the heading of the content credentials. We should be ready to provide it. Let me close with the larger argument. We dedicate substantial financial, intellectual, and human resources to recovering the remains of past human activities. But the knowledge gained from this work is not adequately integrated into local, regional, national, and global strategies for sustainable development. Our ancestors were forced to live in closer harmony with their environment than we are, not because they were wiser, but because their tools left them no choice. Their adaptive strategies, when read carefully, have something to teach us. For that reading to be honest, however, the reasoning behind it must be open. Cognitive nakedness, the willingness to expose to colleagues and to the public exactly what we observed, exactly how we explained it, and exactly which competing accounts we considered are rejected is, in my view, the precondition for archaeology to contribute meaningfully to the sustainable future. There is a prevailing lack of awareness among the public and political leadership about the utility of archaeology in strategy building. It is our fundamental task to analyze human responses to varied environments, natural, built, and social, under the influence of diverse variables. Our work is essential for understanding past behaviors and, by extension, for anticipating future trajectories. The tools exist. Extended matrix give us the formal language. ATON and EMVIC give us the publication channels. Explanation before inference give us the discipline to explain before we infer. Inference to best explanation give us the discipline to compare hypotheses against the evidence rather than against our preferences. DNDCure and other web GIS systems give us the spatial backbone. R and the tools for reproducible research give us the auditable code. And provenance, including the standards now emerging under C2PA, gives us the defense against an AI-driven information ecosystems that no longer distinguishes reality from generation by default. What remains is harder part, a transdisciplinary community with sufficient funding and shared commitment to ethical, multivocal, and openly accessible reasoning about the human past. Thank you very much for your attention, and I'm looking forward for your questions.
Thank you very much. That was a really fascinating talk and a fresh look onto how to apply stratigraphy in a digital way. Yeah, I'm going to let other people ask questions first, but I do have a couple of them myself. So anybody would like to start?
Yes, you can always raise your hand and put it in the chat as well, if that.
All right, I'll take that as a sign. I have a question of how whether your system would be scalable to how, for instance, commercial or salvage archaeology works in outside research. So, because if I would need to, as a field archaeologist, if I would need to justify every bit of my interpretation with regards of what comes first in terms of, let's say, two intercutting ditches, how much more data would I need to add onto a context sheet or so that could be encoded and could be taken into your system of inference before conclusions?
I believe also for salvage excavations, for trench excavations, I believe the very same, maybe, considering the data mining and recording, I believe that it uh, it is the same, absolutely. Considering the reasoning, the stage and all the pipeline that is on a secondary, more complex level. I believe that if you have the data recorded in a proper way, you can do the rest after the excavation is finished. Like the idea was also to, but as I've mentioned at the beginning, this is like a big meditation. This is not a one-man show. And the idea is also to be applied in intensive field